Hi, my name is Renzo Nottitelli, and here you have all my contacts on the social networks. I'm a quality engineer at Red Hat, and on my team we use Python to test Satellite 6, a Red Hat product. I also teach Python online in Brazil in the website python.pro.br. So if you or your company need Python course, get in touch with me. So to be honest, those are the only two slides that I'm going to use on this presentation. I've decided to use a GitHub repository to compare Pytest versus Unitest. So this is why I called this talk the Test Frameworks War. So here on README, I've added 11 features that I would like to compare between the two of them and decide what the winner is. I have already cloned this repository here and created a virtual env so we can install third-party libraries. The first item is installation. Unitest doesn't need to be installed because it's already included on the full interpreter. Pytest, on the other hand, needs to be installed. So let's do that. I'm going to pip install Pytest, and it's going to install Pytest and its dependencies here. So I can create requirements so people can reproduce this code if they wanted to. So here on the first battle, we have Pytest as a third-party library, Unitest as a built-in on the default interpreter. So on this case, the winner is Unitest. So the fact is, if you are going to work in a medium-sized project, probably you are going to need to install another library, so it would not be a problem to install it. But if you are going, let's say, to teach a course like I do for newcomers to the language, and you don't want to teach them about how to install third-party libraries, you can just use Unitest so you can focus only on the concept instead of installing third-party libraries. So let's commit this first one item here. Well, next we are going to have another battle. In fact, the three of them are related, which is the basic infra, basic assertion, flat is better than nested. So let's start with the basic infra that we need to run some tests here. I'm going to create a test package. Inside of it, I'm going to have another two packages, one for Pytest and another for Unitest. So let's start with the older one. First, we need to create a module. So test basic. So basic test case, and Unitest uses object orientation to allow you to make the assertions. So all the time you need it, at least indirectly, inherit from test case from the Unitest package. Look at it here. So to make the first basic assertion, you need to start all the time with the prefix test here and name it test basic stuff here. To make the first basic assertion, the test class exposes some assertion methods. So you can write assert, and you have a lot of them here. Let's use a simple one like assert true, and we are going to make this test pass. Use Python-m Unitest discover, and when you run it, you can see the test result here. So to make a Pytest test case, I'm going to copy the module here, so we can use the very same names. So you need also a module, of course, but on Pytest you can use a class to define your test case, but most of times you can use a plain vanilla function. So I'm going to remove the class from here, and we are going to use only a plain function. Once it is a function, I don't need to define a self parameter here. And to make the assertions in Pytest, we use the built-in assert. So if the expression here returns a true value, the test is going to pass. Otherwise, if it returns false, it's going to fail. To run this test, I'm going to run specific on the directory of the test Pytest, just to run this test. And you can see the test is passing. So for Pytest, your test case can be only a function. On the other hand, for Unitest, you need to create a class and a method to make your assertions there. So once a class is a more complex concept than a plain vanilla function, I would say that Pytest is the winner here. And this brings us to the basic assertion battle. So here you can use the built-in assert. And in the other hand, on Unitest, you need to use test case instance methods. And that's why I prefer Pytest approach as well. The another battle that comes from the Zen of Python, it's flat is better than nested. And once you can use only a function for writing your tests on Pytest, you have only one level of indentation here and one scope. For unit tests, we need two levels of indentation, one for the class and another for the method. So let's fill the unit tests here, and that's why, again, I prefer the Pytest approach. Let's create a commit for that. Battles 2, 3, and 4. Basic, infra, assertion, and nested code. The next feature is if one framework can run each other test cases. Once Unitest was the first one framework of test, and as I told you before, it's included on the full interpreter, it cannot run Pytest test cases. I would say that it doesn't need to because it was not prepared for it. On the other hand, all the new test frameworks, including Pytest, need to run Unitest. Otherwise, people that has a legacy system would not use Pytest because they would have to change all their test code base just to use the framework. So let's go back to the terminal, and you can see that I'm going to change now the directory for the test, the root of our test case, and you can see that Pytest has run both of them. The one from Pytest package, but also the one of Unitest. And just check that when I run Unitest, it will only run one test case. So moving back to the battle, Pytest can run, in fact, Unitest cases, but Unitest cannot run Pytest test cases. So for this battle, again, Pytest is the winner, in my opinion, of course. So for battle 5, test runner. For the feature number 6, we have the test result on the console. For this one, I'm going to make a test a little bit different. I'm going to write 2 tests that are going to fail. So one using a list, and I'm going to use another assertion, assert equal, where I'm going to create a list with numbers and test against another list. Let's say that this one has a different item, the number 5 here. I'm going also to write a test for string. Here I'm going to use assert equal again and let write Unitest with only one t here, and for the second parameter let using 2 letters t here. Let's check the result on terminal. So once we run, check that Unitest present the fails here, present what's wrong, but without context. You can see only the line where the fail occurred, and it's saying that the result is different here for the string. And the same thing we can see for the list. Of course, if you add another item in a list and run again the test, it's going to point the difference here. So bring those tests to Pytest style, transform them on functions. We can have this result, always using the built-in assert here. So using Pytest to run the test case here, you can see that the failing tests are present in the red color, and also it points the different letter when using strings. It tries to show you the difference on the strings, and you can see the same stuff here on the list test. Check that the code, in fact, it shows you some lines around the line that give you the error. So you can see the exact line here and the error message right above the line which is responsible for the failing. So let's say that we can add another line here. So just a variable to the lst and running again. You can see that the line is here. So it provides you some context when a test fails. What I think it's better than Unitest. So returning for the battle, we have error highlight and code snippet for the Pytest, and for Unitest we have only the line error and no highlights. So that's why I prefer Pytest again. So let's add a commit for it. Battle 6, result on the console. For this one, I'm going to create a new module. So test mode paran, and I need to create all the boilerplate code from Unitest here. So I need to import the test case class again and create a multi-parent test case and method. To give you an example, let's say that we want to test a bunch of values. So I'm going to use a range, start in 0, going to 10, and I'm going to check that this number here is 0. So I'm going to use assert equal, comparing 0 to I. If I run the test case, it's going to pass for the first value of I, fail for the value of 1, but it will not run for 2, 3, 4, and so forth. Let's run the test case, and you can see the error here. The thing is, sometimes you want to run a multi-parent test where we are going to use a lot of values, but even if it fails, you want to check for the another parameters here. So I would like to check for 2, 3, and so on. To do that on Unitest, you need to use a context manager. So you use with subtest, and you can pass a name here so you can identify the value. Let's say I'm going to pass the I here so I can know what it's going to do. And check that now we have 4 levels of nesting stuff here. Let's run the test case again. And now you can see that all the values were tested. What it's doing, it's even with this test, it's somehow putting the test result on memory, but it will keep testing the following parameters here. So you can see the 9 here, and the next the 8 and 7 and so forth. For Pytest, I'm going to create the same module, and I'm going to create the tests with multi-pattern stuff. So to create a multi-pattern test, the idea is keeping the function flat here. So we are going to assert the value against a parameter here that I will call value. To do that, you can use a decorator from Pytest, which is the parameterize decorator. We need to import Pytest on this case, and here on the decorator, we are going to tell all the parameters of value. The first parameter here needs to be a string having the same name of the parameter here, so value. The second parameter is a table telling the values that you want to use. Let's put the same one that we have used on the unit test case. So let's test only the Pytest one with the test mode parameters stuff. So we can see the very same result here, like for the 9 and for the 8 and so on. But keep in mind that the test itself, it's not so nested as the unit test one. If you have more parameters, let's say an I here, we could add it on this string, like this one. You use comma to separate the values here. You insert the another parameter on the function here, and you could pass a list of values where each one, of course, is going to be a tuple with the 2 values. So 0 will be on the value and 1 will be on the I parameter here. Let's just add an assert here so we can check on that. Running again, and you can see that this one test passed. Okay, I'm going to return to the original example of the range 10 for our battle. So returning to the README, we have Pytest with parameterize and keeping the code flat, and we have subtests increasing the nested code here. And for this reason, I think Pytest is the winner again. Let's add commit battle 7 multi-pattern. Now let's check the battle number 7, test setup. So let's say when you are using a framework like SQL Alchemy, where you have a connection with the database, that it's a costly operation. So you don't want to do that a lot. Ideally, you want to open the connection on the beginning of your program and close it only on the end. On the other hand, we have a section which is cheap. Once you have the connection open to your database, you can open cheap DB sections, and what you can do in a session is holding back all the test cases. It's very common when you use a framework like Django. So when you are running a test case, you are going to save some stuff on the database, and after each test has finished, you can hold back the database so you don't have a state on the database. You always have a clean, an empty database when you are running each test case. Another thing is that for this battle, I've also created a test setup here with two modules, test 1 and test 2. On the test 1, I've created a pretty simple test that would test the database save and a test database delete. So check that for both tests, I would need a database connection and of course a session where I could save and delete it. So to define a setup for your tests, Unitest uses the template method design pattern, where you have some root methods which are going to be executed just before the test and after the test case. The first one that we are going to use is the setup. Since we need a new session for each test case, what setup do is a root method which will be executed just before each test case inside of this class. So let's create a session on the setup. Of course, we need to import it from the setup classes that I've created. Check that on each test case I'm printing hashtags here and also on the code of the creation of sessions and when you close it. In fact, both session and connection. I've done that so we can run the test case using grep. So let's run the unit test and you can see that before running delete we have the opening chip DB session and number 1 we have opening the first session, and for the second one, the test running save, we have also opening a test. The issue that we need to solve here is that we need, after the test case, we need to close this session. Let's go back to test 1, and to do that we have the method teardown. Here you can see the template method. Unitest is going to run setup before each test and teardown after it. The only issue is that the logic of creation of a session is segregated from the logic of its destruction. So what I need to do is creating an attribute on the test case itself for this one. So I'm going to create a session here so I can access it on teardown just to call the close method so we can roll back all the stuff that we have saved on this test and roll back all the deletion that we have made on this test here. Running tests again, you can see that we achieve our goal. We are opening the session just before the running delete and rolling back all the changes after the test case. So we have a clean session when we start again, a second session here for the running save and rolling back after that. So once you understood the concept of setup and teardown, we need to create almost the same stuff for the connection. So now we need to create a connection, but the difference here is that we are going to create the connection before the test switch execution and only once, and after the test execution we need to close the connection. To do that, we have the two connected tests. The first one, to create the connection, we can override setup class. Check that it is connected to the class itself and not to an instance. So it is a class method here. Just similar to setup class, we need to override another method for setup, which is the teardown class that is going to be executed only after all the switch test execution. Of course, we need to create a connection here just like we have done, but connecting in a class attribute. Here we are going to create a connection. We are going to import the connection from setup classes, and here on the teardown we are going to access this connection to close it. Let's execute the test again, and you can see the result here. The costly operation is just being executed on the beginning of the test execution. We have a session being created before it tests and being rolled back after its execution. And after all the test suite execution, we are closing the connection here. Well, the problem that I see with this approach is that you check it that you have some boilerplate to build before using a test case. And sometimes people just see, okay, I need to add a test case which is somehow related to test one, let's say in a semantic way. And once you have to create a class and some stuff, people just reuse the class and just add another method here to add a new test. But let's say that this new test case, it's not related to the database. So let's say test non-DB, and this is a non-DB test case. What's the problem here? You will run a non-DB here, and you don't have to create the boilerplate. But of course, the issue that we have here is that we have a non-DB test case which has an opening session for it and closing a session and wasting resource here. Also, we kept the connection open when this test is running. To show you something, let's say that we have a test pretty similar to test 1 and that we want to use all the setup again. And let's just copy the code. That is not something that you want to do. Remember that when you are copying code, bad things can happen. And let's put here just a number 2 here and 2 so we know where the tests are coming from. Well, when you do that and you run your test case again, let's check what happens. Check that there are 6 sessions being opening, of course, because we have 3 tests from test 1 and another 3 from test 2 module. But check that we have a problem. The connection here is being created for the running delete, which is the first one. And check after that the connection is being closed just after the running of the test 1 module. And that's the problem, because if you are wasting time, you could reuse the connection number 1. A first try to address it is that once you are reusing the setup here and the tests are different, you can use object orientation to avoid that. So let's create a basic module here and create a setup base test case class. Of course, it needs to extend the test case from Unittest itself. So now what we can do is, instead of extending test case, we are going to extend this setup base there that I've created. And what we are going to do, we are going to move all the setup methods to this base class. So let's do that. Let's use the setup using the refactor and pull members up. We are going to move setup class, tear down, setup, and this one, this 4. Let's refactor it. So now we have all the setup methods moved to a base class. They are here. And now on test 2, we can also refactor and use the setup base here. And of course, we can get rid of the setup methods. Look that the code is pretty much cleaner. You are not duplicating code. But let's run the unit test again, and you can see that even by doing that, you have two connections being created. And the issue here, you only have the setup which will be executed before the test, and you have the setup which is related to the class scope. So you have a method scope and we have a class scope for the setup, and only that. So now let's see how Pytest deals with this setup. Let's copy the test setup there. Let's delete base. Let's transform tests on Pytest test cases. Now that we have pretty similar test case to the Unitest version, let's try to address the issue here. The first thing that we have done is create a session before each test. To do that, we are going to use the concept of Pytest fixture. To create one, we need to use a decorator here using Pytest, which is named fixture. Let's import Pytest. And we are going to create a session here. By default, this session is going to be a fixture, and its scope is pretty similar to the one that we have used on the Unitest version. Since we just need to create the session and not being available on the test itself, I'm going to do the same stuff that I have done on the Unitest version, only creating the session. A second thing that I need to do is telling on the test which ones need a fixture, in this case section. This is done just like we have saw on the parameterize. Once you have created the fixture, you need to use the same name here as a parameter for the test functions. So let's do that here and here. By adding this parameter, we are explicitly telling that the be safe and the be delete need an open session, and this is a nice way to not include tests that you don't want the session being created for, just like this test non-db stuff. So let's execute the test case. The one thing that I've done is adding the -s option. The reason is that Pytest will not show you the strings that you send to standard out, so you need to add this option here. Thus, executing the test, we have a pretty similar result to the execution when you use the setup method on Unitest. Now we need to close the session. So how we do that? The thing is if you need access to session, you need to return in fact it. I haven't because session was not used on this case. So if you have a fixture that you don't need to do some close, some tear down stuff, you just use the return. But if you need to close this session, let's put it in a variable here. You are going to use a generator function to do that. So we are going to yield this session, which will be returned on the task that need to use it. And after the yield, you can put the tear down logic for it. So you can put the close here. Let's execute the test again and check the result. So you can see that after each test, the session is being closed, just like on the Unitest example. The issue now is that a session is not being opened for the test 2 here. In fact, when you create a fixture inside a module, it's only to be available on this module. So even if I go to the test2 test case and put a session in here, we are going to have a problem because session is not available on another modules. So to solve that, you can create a module called conftest, which is a convention on Pytest. So let's move session to a module called Contest. Let's refactor, and you can see the contest here with our fixture, and we have the session here. Let's execute it. So you can see that now running save to is executed, and it has access to the session itself. What we are missing here is using session on db delete. Check that we are using a parameter here which is not used on the test itself. Sometimes it's not a good thing to have a parameter that it's not used. It can confuse someone, and someone can remove that from here because he is not aware how the Pytest fixture works. To be more explicit about what we are doing once we are not using this parameter here, you can use also a Pytest decorator, which is use fixtures. You can pass here several strings telling what fixtures this test wants to use. So now when we run the test again, let's check that delete2 is also using the session. But let's say that on test 2 we have all the tests need to access this session here. So instead of repeating all the time this kind of stuff, we can just change it a little bit. We are going to use the same function that is present as a decorator. We are going to remove the parameter here, and we are going to create another convention from Pytest, which is Pytest mark, and we can put here the use fixtures. When you do that, all the tests inside this module are going to execute that fixture. So let's run the test again and checking that this session is being created and closed after the test present on the test 2 module. To complete the example, we are missing the connection creation. Let's copy the code here, but changing all the session stuff to connection, and also change this for connection. Of course, if we use these fixtures as it is, it's going to create a connection for each test, and we don't want that. You can control the scope of the fixture using this parameter here. The default is function, which will create a connection for each one. And once we need to open the connection for all of our tests, we can use an option here, which is auto use equals true. This is also a way of telling that this fixture needs to be available to all the tests under test setup package. When you do that, you can see that that connection is being created and closed for each test case. So that's why we have 5, because we have 2 tests here on the test 2 module, but we have 3 here with the test non-DB stuff. But that is not what we want. Another scope that is available is the Mojo Scope. It's going to create the fixture on the beginning of each module inside this package for each module. So let's execute it and check that again 2 connections were created because we have 2 modules here. But once we want this connection be created only once during our test execution, you can use the scope session, which means the session of test execution. Once we do that, you can check that a connection was created on the beginning of test execution and was closed on its end. For test setup, Pytest provides fixtures with module, session, and function scope, and Unitest provides through template method design pattern the method setup, teardown, teardown class, and setup class. But because of the more granular control that we have on Pytest, we have it as the winner again. Let's commit this code. So for battle number 8, we have the setup stuff. Once Unitest seems to be losing this war because of so much battles, so I would like to mention something that it's not pleasant on Pytest, at least for people that uses an IDE like me, which is name refactoring. The IDE cannot be aware of the black magic that Pytest does to inject fixtures, parameters, and stuff. So if you decide to rename, let's say, the section here, it's going to only refactor the tests that are using session as a function. So let's say that we are going to rename that only that. If you refactor this, you can see that it's not going to check on any code because there's no way the IDE knows that when you are declaring this section here or when you are using this string here, that they are related to the fixture itself. So we need to move back here this kind of stuff. And if you are going to refactor, to do a rename, you will need to do a sort in comments and strings and for test occurrence. So you can really be sure that all the things that are related to this fixture are renamed as well. On the other hand, once Unitest uses plain vanilla setup classes and test case, if you decide to, in fact, you don't have to change anything. So if you decide, let's say, to rename the session here for SES and you refactor, the IDE knows that this is an attribute and it's going to change everything for you. So for this battle, the one related to name refactoring, if you use an IDE, you will have a poor refactoring because of the name conventions that Pytest uses on its code base to do its black magic. On the other hand, Unitest use regular object orientation and we will not have this problem. So I will put here Unitest as the winner for this battle. Let's commit it. So the battle 9 factory. For the last battle, we have running failed tests. That's something very useful. Let's run our entire test suite using Pytest, and now all of the tests include the ones from Unitest. You can see that we have 14 failed tests and 14 passed tests and 14 passed tests. Sometimes you just fixed those failed ones and you want to see executed only these failed tests on last section. For this, you can use an option here which is LF for last failed. So let's run it again, and you can see that the 14 failed tests got selected on this test execution, and the 14 which were not failing were deselected from this test execution. Another thing that you can do, you can just use the FF option, which will fast forward the failed tests. What it's going to do, it will run the failed tests before the ones that didn't fail on the last execution. Unfortunately, Unitest don't have this feature by default. So going to README again. For failed tests, Pytest provides a built-in options like LF and FF options, but on Unitest, you need to provide your own way to run only the failed tests. So that's why, again, Pytest is the winner. Let's commit it. Failed tests. So for our last battle, we are going to analyze the feature marks. You use this feature when you want to mark some tests and group them so you can run only those grouped tests. We have both here on test 1, this test non-DB stuff, and we would like to maybe group the tests that are non-DB stuff because they can run very fast. So you can use the Pytest here, and you can use mark, and let's create a mark called non-DB. And just to show you that Pytest can work fully with Unittest, we are going to mark this one here as non-DB as well. Of course, we need to import Pytest here, and also the one from test 1 module, again importing Pytest. So after grouping those tests, we can execute the test case using the -n option, which means mark, and we define the marks that we want to filter for this test execution. So let's execute it, and you can see that only the non-DB test case were executed. Returning to README, unfortunately, Unitest does not provide an easy way to do that. You can execute tests inside a directory, but it would mean that you need to change your project organization, and sometimes you don't want to do that. So for marks, you have built-in marks on the Pytest stuff. On Unitest, you are in your own, and again, Pytest is the winner. So this is the end of this presentation. I hope you get a great overview of both frameworks, and this talk can help you to decide what to use. I hope you have enjoyed this talk, and thank you for your attention.